Let's go a little further. Let's add some veins. So what we're going to do is use some techniques that we've used in other parts of this tutorial series to make some veins on this sort of nasty looking thing. So what I want to do is sort of similar to the way that I generated the internal structures for our cube. I want to create a whole bunch of splines and then use the find shortest path to actually generate this kind of branching vein network. So in order to create the splines, I'm going to need some points to start connecting. In order to do that, I'm going to use a scatter sop. So this time let's actually get it. There we go. Scatter sop on the surface. I don't want to do this in the volume. I am just going to do this on the surface. So we're going to go in here, we're going to turn off relax iterations, and I'll start with 1,000 points by default. I think that's probably fine. We want to do connect adjacent pieces so that we get actual lines between our geometry. And remember, with the connect adjacent pieces, we need to change the connection type to adjacent points. Cool. So I think that's probably sufficient. I think that looks pretty good to me. We want to fuse them to make sure everything is connected and not disconnected from each other. Now we need to make a couple groups. So we are going to throw in a group sop to generate our start group. And this needs to be a point group. Let's start. And we're going to turn this off, and we're going to turn on keep by bounding regions, and we're going to use a bounding sphere, sort of like what we did before. And we're going to take that bounding sphere, we're going to move that over here, because I kind of want these veins to start where this, the main sort of bulk of the mass is. Feels a little bit more realistic that the bigger veins, you know, the veins would branch out from the bigger areas to the smaller areas. And maybe we go like a little underneath. We can always change this later if we don't like what we get. That's probably fine. So those would be our start points. And then let's do a group expression for our end group. And we're going to do point group, call this end. And our group expression here is going to be rand at ptnum less than, say, 0.5. Okay. So there's our start and end group. Now we'll do our find shortest path. Throw that in here. We'll tell it to start at the start group and end at the end group. And we want to do from any start to each end. Nope. I lied. From any start to each end. There we go. That's the one. Cool. Now we need to take these from being these kind of angular shapes, and let's make them more organic by turning them to Bezier curves using a convert sop. We'll do the convert sop. Convert these to, NURBS curves, and then convert them back to polygons, like this. And then we want to change the scale of them as they go from over here where they should be big to all the way out here where they should be small. We want to vary the scale. So in order to do that, we're going to use a UV texture sop to generate UVs along our splines. And let's say rows and columns and point class. So now we should have UVs on our points, and we do. Let's throw in a color just to check and make sure what direction those are going. So if we set the ramp from attribute to UV, there we go. We can see the green end is where it's going to start and the yellow end is where it's going to end. So we'll go from big to little. Great. Now, we're going to turn these into a VDB, and much like we did up here, we need a p-scale attribute in order to change the size of this. So we're going to use the UVX parameter coming off of our UV texture, our attribute UV. We're going to use our UVX attribute coming off of our UV texture SOP, and we're going to turn that into a p-scale attribute. We're going to run an attribute wrangle. I'm going to say at p-scale equal to at uv.x. Okay, and then we'll do our VDB, but we're going to do VDB from particles again. And it's gigantic and way out of control. So we're going to reduce the minimum width. We're going to reduce this point radius scale. And we need a lot more voxels in here to get this to read properly. That's looking a little better. Still not right, but you can tell we're actually backwards again, which is fine. We can fix that. Let's go 0.001 so we get nice smooth voxels. There we go. That might be a little excessive. Go 0.005. And we also need some more points in here. So let's first of all solve our scale issue, because we have a scale issue again where, because we're down here at the end, this is the small end, and then it gets bigger as it goes along. I actually want to reverse that. So let's do that in here. Let's do that similarly to the way that we did it before, where we throw in a fit expression. We take at uv.x, we say this goes from 0 to 1, and we want it to go from 1 to 0, like that. So that'll flop it around. There we go. And maybe we don't want it to go all the way to 0. Maybe we want it to go to like 0.25. Yeah, that's probably okay. Now, the other thing we want to do is I want to add some more points in here, because you can see we don't really have that many points going on, and you can actually see those points. When we turn it to VDBs, you can see every single point in there. I want more points so that that doesn't happen. So for that, we're going to use a resample SOP, and that just resamples our spline. So if we look at the resample SOP before we pipe it in anywhere, you can see this is what it used to look like. This is with the resample. So what I'm going to do is say resample by polygon edge. We're going to say by segments like this. That's cool. So that should be plenty of points. So now if I go down here, I shouldn't see any more of those gross gaps. That's way better. Let's also reduce this number down to like 0.1 so we get a little bit more extreme. Maybe we start at like 1.5. All right. Cool. Let's merge this. Oops. Let's merge these things together after we do a VDB convert to get polygons out of this again. Let's get some polygons out of this. And polygons. There we go. Turn off point mode there. All right, so there's my sort of nasty looking veins. Let's combine that together with our other polys. Yeah, that's sort of gross looking, right? You see those veins like running through, looking pretty gnarly. Yeah, that's cool. I'm digging that. All right, so we do definitely want to make sure that they have their own path attributes. So we're going to throw in an attribute wrangle so that I can texture the main mass separately from the veins. So these need to be primitive attributes. S path. I'm going to call the main mass organic mass. And I'm going to duplicate this. I'm going to call this veins. Oh, don't need two of those. Okay. Then we can take the output of that and we can run it right into our main merge. And let's look at the result. Let's look and see how that looks with everything else in here. There we go. So now we've got this like crazy growth out the side of our cube, which is like that looks pretty nasty. Digging that pretty well.